5.3 common factors. So we're going to look at factoring now opposed to expanding. So factoring and expanding are basically the opposites of one another. So factoring a polynomial is the opposite of expanding a polynomial. And factoring is the process of writing a polynomial as a product of two or more polynomials. Okay, so when we expand, we get the one on the right. We get something that looks like this. Okay, however, when we factor, we get something that looks like this. So first we're going to touch on greatest common factor. Okay, factoring by using the greatest common factor. So the greatest common factor is the largest number or variable that divides evenly into each term of the polynomial. So in order to find the greatest common factor of the polynomial, what we want to do is we want to find specifically the greatest common factor of just the coefficients. So what we're going to do is we're going to look at the factors of each coefficient. Then what we're going to do is we're going to find the greatest common factor of the variables. So we find a variable that's common in all terms. Say it's x squared. Okay. Then what we're going to do is the greatest common factor will be the variable, like that variable with the smallest exponent. But each and every term has to have that variable in it. And then please note, a variable is only a part of the greatest common factor if it appears in all of the terms. Okay, so let's go ahead and find the greatest common factor of the following. So we have 8x and 24y. So when I think of the number 8, I think of the factors 1 and 8, 2 and 4, and that's it. When I think of the number 24, I think 124, 212, 3, 8, 4, and 6. So the greatest number that these two have in common is this 8. So we can factor out an 8. The greatest common factor is therefore 8. And I just want to point out, I didn't touch on the variables. However, the variables are different. There's only an x in one of the terms and a y in the other term, so we can't factor out either. So the greatest common factor is 8. Okay, next one, 9x squared and 12x to the 4. So let's take a look at the numbers first. I get 1 and 9, 3 and 3. Okay, and out of 12, I get 1, 12, 2, 6, 3, 4. So what is the greatest number there that's common? Well, 3 and 3. So we can definitely divide a 3 out of each of these. Now, let's take a look at x squared and x to the 4. Well, yes, there's an x in each of these terms. So what we're going to do is we're going to take the x with the smallest exponent, which is the x squared. So the greatest common factor is going to be 3x squared. Okay, 2x squared y, and then 16xw. So 2, the factors of 2 are 1 and 2. The factors of 16 are 1, 16, 2, 8, and 4, 4. The largest common one is 2, so the greatest common factor will definitely have at least a 2 in it. Now let's compare the variables. We have x squared y, and we have xw. So what's common? Well, the x's are common. So we're going to take the x with the smaller exponent, which is just 2x. Okay? The bigger exponent is obviously x squared, so the smaller exponent is x to the 1. Okay? This is supposed to be D. All right. 9 and 27. So the factors of 9 are 1, 9, 3, and 3. The factors of 27 are 1, 27, 3, and 9. The greatest common factor for the coefficient is definitely going to be this 9. Now let's take a look at the variables. We have We have x squared and x to the 4. So the x's are common in both, so we take x squared because it's the smaller exponent. Now w3 and w5, like w cubed and w to the exponent 5, w is common in both, so we take the lower exponent, w cubed. Okay? All right, next, 16 and 12. So the factors of 16 are 116, 28, 44. The factors of 12 are 112, 26, 34. The common factor I see here is 4. Okay. Then we have x cubed, x to the 5. So the greatest common factor is going to be 4x cubed, because cubed is smaller than 5. But just to point out, x is common in both terms. Okay, we can also see common factoring with like a trinomial. So breaking this down, I can look at this and I can know that the greatest common factor is going to be 5. But if you still have to write these out, like 1, 25, 5, and 5, okay, just by default, 25 goes into 50, but 25 doesn't go into 30. So those are not going to be it. It's going to be 5. 5 goes into 50 and 30. And then let's take a look at the variables x to the 1, x to the 1, x to the 1. Well, x to the 1 is common in all of them. Y, Z, W. Okay, there's only one Y, one Z, and one W, and they're not common in all of them, so that our greatest common factor is just 5x. Okay, so we've found some greatest common factors, so now let's actually factor. Okay? So in order to common factor, what we need to do is we need to find the greatest common factor and then divide each term by that greatest common factor to find a second factor. And how we write it is we write it as the greatest common factor, bracket, and then what's left over, or basically what we have is the second factor. And we're not going to do this at first, but we can always check our answer by expanding. Okay, so we said the greatest common factor, we did this up above. It here was 8. So what we'll do is we'll divide both of these terms by 8. Okay, so we write our greatest common factor, bracket, what's left over. 8x divided by 8 is x. 24y divided by 8 is 3y. Okay, so this one's new. So we're going to actually find a greatest common factor. So for 9, we have 1, 9, 3, and 3. For 36, we have 136, 2, and 18, 3, and 12, 4, and 9. Okay, as soon as like the first coefficient goes into the second term, we're going to take that like the entire coefficient, so 9. And we can stop there. I mean, you can keep going 6 and 6, that's fine. So what we're going to do is we're going to divide it by the greatest common factor, which is 9, and then looking at x squared and x, yes, x is common in both terms. So we're going to divide by 9x because we're taking the lower exponent. Okay, we write 9x as the greatest common factor, and then 9x squared divided by 9x is just x, plus 36 divided by 9 is 4, x and x cancel out. Okay, 9x, x plus 4. Okay, example C. Let's find the greatest common factor. So we have 6, 18, and 24. And immediately I know that 18 divides by 6 and 24 divides by 6. So the greatest common factor is going to be this like entire whole number. If you need to go through the steps, that's no problem. We can go 1 times 6, 2 times 3. Those are the factors of 6. We can write down the factors of 18. 118, 29, 3, 6. And we can write down the factors of 24, which are, as soon as we get into like bigger numbers, as long as they're not prime, they get pretty lengthy. 124, 212, 3, 8, 4, 6. Okay, so we can also see that the greatest common factor is 6. Now let's look for common variables. We have an x term or an x variable in each term with the lowest exponent being 1. So our greatest common factor is 6x. So what we'll do now is we'll take this entire equation. So we have 6x squared plus 18 x cubed w minus 24 xz. And we're going to divide each term by 6x. Okay. Now, how do we write this? We write the factor first, bracket, and then we divide. So 6x squared divided by 6x leaves us an x. 18 divided by 6 leaves us 3. X cubed divided by x leaves us an x squared, w. Okay. Negative 24 divided by 6 is negative 4. The x's cancel out, and we are left with 4z. So this is the factored form of this equation. Okay, now the last one, 10 and 20. So I know that 20 divides by 10, so our greatest common factor is going to be the entire 10, but we can write this out if you need to. So the factors of 10 and then the factors of 20. Okay? So the greatest common factor is indeed that 10, and we have an x squared and an x to the 5. So our greatest common factor will be 10x squared. Because it's the smaller exponent on that x. So x squared, x to the 5, the smaller exponent is going to be that 2. So we have 10x squared plus 20x to the 5. And we're going to divide both terms by 10x squared. Okay, don't let this fool you. 10x squared divided by 10x squared does not go to 0. These cancel and go to 1. Okay, so let's write 10x squared as our factor. 1 plus 20 divided by 10 is 2. X to the 5 divided by x squared is x to the exponent 3. Okay, let's do the next one. We have 8, 4, and 12. I know all three of these actually divide by that 4, but if you need to see them, 1, 8, 2, 4. 4 is just 1, 4. And 12 is 1, 12, 2, 6, 3, 4. Okay, so we can see in these terms, 4 is common. 4 is a common factor of each of these terms. Okay, now let's take a look at our variables. Okay, we have x squared, x cubed, and x. So that's good because now we see that we have x in each one of these terms. Okay, the lowest exponent is that 1. Okay. We have y to the 4, y squared, and y to the 5. The lowest exponent is that squared, y squared. So now, when we rewrite this and we divide each term, okay, divide each term by 4xy squared. Okay, so we put the greatest common factor in front, which is 4xy squared. And then in the bracket, what we do is we divide. So 8 divided by 4 is 2. The x squared cancels with the x and leaves 1x. The 4 and the 2 cancel and it leaves y squared on top. Okay, so remember exponent laws, when we divide, we just subtract the exponents. Okay, 4 divided by 4 is just 1. X to the x cubed over x to the 1 is just x squared. And these y squareds cancel out. Okay, negative 12 over 4, we get negative 3. The x's cancel and the y's go to y cubed. And that's how we factor that. All right, last one for this section. I'm going to skip these steps. So greatest common factor. I know that 12 divides by 6. So our greatest common factor is going to be that 6. Now x cubed and x squared, we're going to choose x squared. X is common in both. We choose the lower exponent. Y to the 1 and y to the 4, so we just divide by y to the 1. Okay, so 6x squared y and 6x squared y. 12 divided by 6, oh, sorry, first write the factor. 12 divided by 6 is 2. X cubed divided by x squared is x, and the y's cancel out. Negative 6 divided by 6 is negative 1. X squared cancel. X to the 4 over, sorry, y to the 4 over y leaves us with y cubed. Okay, so please note the greatest common factor is not necessarily a monomial. So all the ones that we've seen so far are monomials. Now it can also be like a binomial, and it can also be a trinomial. Okay, so let's take a look at these. Factor the following. So we're going to look at these two terms. So this right here is one term. And remember, terms are separated by plus and minus signs. So this right here is another term. What is common between these two terms? Well, the x plus 2 in brackets is common between those two terms. So we're actually going to use the x plus 2 as our common factor. So our greatest common factor is x plus 2. And I'll leave this in brackets. Okay, so let's put the x plus 2 here. Now, x plus 2 over x plus 2, those cancel and leave us with a. X plus 2 over x plus 2 cancel and leave us with plus b. This is coming back. Okay, so remember how to do this. Let's take a look at it again. This right here is one term. This right here is another term. What is common between these two terms? Y minus 3. Okay, so the greatest common factor is y minus 3. When we divide, the brackets cancel out. So we write the greatest common factor first, y minus 3. Then we're left with 2, and then plus 7x. And we can rearrange this just so it's more simplified. And I would just put the x term in the front. So 7x plus 2. And then I would put the y minus 3 after that. Factor by grouping. So we're going to look at factor by grouping, and usually this is done when we see 4 terms, okay? Not all the time, but many times. So what we want to do is we want to group 2 terms together that share a common factor. So I'm just going to actually apply these right into question 4a. So bx and 3x share the x, so that's a common factor. And by and 3y share a y, so that's a common factor. So all I did here was I just grouped the 2 terms together that share. And now what we're going to do is we're going to find the greatest common factor of bx and 3x, which is just x, and we're going to factor out an x just out of that first grouping. Okay, so we're left with b plus 3. And in the second grouping, by plus 3y, we can factor out a y. Okay, and we're left with b plus 3. And we're done now factor by grouping. What we want to do now is factor out the binomial. Okay, so we can see that b plus 3 is common in this term and in this term. So this time, b plus 3 is going to be our greatest common factor. And we can write b plus 3 here. And what do we have left in the first term? We have x left. What do we have left in the second term? We have a y left. So our factor is actually b plus 3, x plus y. Okay, let's try the second one. So first let's group. Ax and ay both have a's. 2x, 2y both have 2's. So let's factor out an a out of the first two terms. We're left with x plus y. Let's factor out a 2 out of the second two terms, out of this grouping. And we're left with x plus y. Okay, we're going to factor out an x plus y out of both of these terms. And that's going to be our greatest common factor for this, x plus y. And we're left with a plus 2. Okay, let's go to C. So 9x squared and 15x, we can pull a 3 and an x out of those. So let's group those. And then in the second grouping, I don't see anything, but let's just group them and then see where we go, okay? So let's pull out a 3x. Oh, write a 3a. Okay. And 9 divided by 3, I'm going to write the factor first. 9 divided by 3 is 3. X squared divided by x is x. 15 divided by 3 is 5. X divided by x goes away. Okay, so how is saying that we can't really pull anything out of that second bracket? We would technically be dividing by 1. Okay, and what's left in the bracket when we divide by 1? Well, 3x plus 5. And sometimes we're going to see questions like this. So our greatest common factor here is going to be 3x plus 5. So our factor is going to be 3x plus 5. And then bracket 3x, and then this plus 1 here. Those are our two factors. Okay, last one. 8 and 24 both have 8. We can divide by 8. Negative 7xw, and it's important to actually include this negative. So negative 7xw and negative 21 yw, both of these we can pull out a negative 7 and a w. Okay, we're left with x plus 3 y, and negative 7 divided by 7 is just 1. W's go away, so we're left with x plus 3y again. Okay, and the whole point of this is to get these two as common factors identical. Then we might have done something wrong. Okay, so x plus 3y. And it is possible that it just can't be factored by grouping. Okay, so our one common factor is x plus 3y, because that's in both terms, right? Those go away. And we're left with 8 minus 7w. Okay, last one. Always look for a common factor first and then try to factor by grouping. Okay, so that common factor, this is going to play a huge role. Pull out whatever you can and then try to factor by grouping. So in this, I can see that I can pull out at least a 7 out of each term. And then let's check, no, so we have x's in 3 of these terms, but not in this 105y. So we can only divide by 7, which is fine. It's going to make our numbers smaller and nicer. Okay, so we're left with 7 as the common factor, x squared minus 3y plus 15y. Oh, this is yx. And then minus 5x. Okay, so now this 7 doesn't play a role when we factor by grouping. So let's group, the first two terms have an x in it, so let's try that. And the second two terms have a 3 in it, so let's try that. Okay, so let's just bring down the 7 and leave it. I'll go darker. Okay, bring down that 7 and leave it. And then we're going to factor an x out of the first two terms. So let's just put a big bracket. Okay, the first common factor is going to be x, and we're left with x minus 3y. And then let's divide by 5, so plus 5, that's going to be the second factor, and we're left with 3y minus x. All right, let's take a look here. This x and negative 3y, and then we have positive 3y minus x. When we have something like this, what we actually have to do is all we do is factor out negative 1 out of one of them, because what we're trying to do is negate every single sign. So x and negative x, we want that negative x to become positive. We want this 3y to become negative. So let's just copy everything down. And then now we had a factor of 5, but now we also have a factor of negative 1. So we can skip the step and just put in negative 5. And this changes to minus 3y plus x, but I'm going to rewrite it as this factor, x minus 3y, same thing. We can just rearrange those. Okay, now we have the brackets looking identical. Okay, so let's bring down the 7. And then what we did is we factored out x minus 3y. What's left? X minus 5. And that's it. Okay, next one. What can we factor out of each term here? We always want to check that first. We can factor out an x. So let's go ahead and factor out an x. And we're going to be left with x squared minus 5x plus 6xw minus 30w. And now from here, we want to factor by grouping because we have 4 terms. So x squared and negative 5x both have an x in it, so we can group those. A 6 and 30, we can pull out a 6. xw and w, we can pull out a w. So we can group those. So now, bring down the x. This one just stays as it is. And let's bring this down a little bit more. Let's divide the first bracket by x and the second by 6w. Okay, so our first common factor is going to be x, and we're left with x minus 5. Our second common factor is going to be positive 6w, and we're left with x minus 5. Which works out perfectly because now our common factor is x minus 5. Divide both terms by this. Now, we had a common factor of x minus 5, and what's left over is x plus 6w.